First seconds of a new age, the age of artificial intelligence. It appeared suddenly, and now it is everywhere. It powers the art we create, the questions we ask, the cars we ride in, and the very code that runs our world. It seems like magic, an intelligence that emerged from the network itself. But it isn't magic, and it didn't come from everywhere. The entire multi-trillion-dollar AI revolution, every single part of it, depends almost entirely on a single piece of hardware made by one company: NVIDIA. You might know them as the company that makes your video games look good, but in the last few years, they've become arguably the most important company in the world. How? How did a company that made hardware for teenage gamers secretly position itself to hold the keys to the future of civilization? This wasn't an accident, it wasn't luck. It was the result of a single, monumental gamble made nearly 20 years ago, a bet so risky and so far outside their core business that almost no one understood it. This is the story of how NVIDIA saw a future no one else could and quietly built the engine that would power it. To understand the gamble, you have to go back to the beginning. The year is 1993. The place? A Denny's in Silicon Valley. Our main character is Jensen Huang, a leather jacket-wearing engineer with a vision. The world of computing was changing. For the first time, visual graphics were becoming as important as raw processing power. The problem was, the main computer processor, the CPU, was terrible at graphics. It was a generalist. Huang and his co-founders believed the future required a specialist, a new kind of chip designed to do one thing and one thing only: process millions of parallel calculations to render realistic 3D images at lightning speed. They called it the Graphics Processing Unit, or GPU. But they weren't alone. The 90s were the Wild West of the graphics card industry. Dozens of companies were locked in a brutal war. It was a chaotic, bloody market where today's king was tomorrow's forgotten relic. For years, NVIDIA was just another player in the pack, an underdog fighting for survival in the cutthroat world of PC gaming. Their entire existence was defined by one simple question: how do we make video games look better? That was their entire world. But deep inside the architecture of their gaming chips, a hidden power was waiting. A potential so vast, it would one day make video games look like a trivial rounding error. For nearly a decade, NVIDIA fought and survived the graphics card wars. They won a landmark contract to build the graphics hardware from Microsoft's first Xbox console, cementing their place as a top-tier player. Their world was gaming, their audience was gamers, and their business was selling millions of graphics cards, each one slightly better than the last. But while the world saw a hardware company, Jensen Huang saw something else entirely. He saw a software company trapped in the body of a hardware company. He realized that the raw power of his GPUs was locked away, accessible only to expert graphics programmers. What if, he wondered, he could open it up to everyone? What if a scientist, a researcher, or a financial analyst could use the thousands of tiny processors inside his gaming cards to solve their own complex math problems? This was the genesis of a project that would change the world. Its name was CUDA. CUDA, which stands for Compute Unified Device Architecture, was a revolutionary software platform. It was a key that could unlock the hidden parallel processing power of NVIDIA's GPUs, making them fully programmable for general-purpose computing. For the first time, a scientist could take a massive, complex problem like simulating molecular interactions or modeling weather patterns and run it on a cheap, consumer-grade gaming card, getting results hundreds of times faster than on a traditional CPU. But this revolutionary idea was met with massive internal resistance. It was a bet-the-company gamble. Developing CUDA would cost over $500 million and divert their best engineers away from the core gaming business that paid all the bills. His own executives argued against it. The market for this scientific computing was tiny, maybe a few thousand researchers worldwide. They were a gaming company, they argued, and this was a dangerous, expensive distraction. The logic was sound, the risk was enormous. Pursuing CUDA meant sacrificing short-term profits in their main market for a non-existent theoretical market of the future. The pressure to abandon the project was immense. Jensen Huang was faced with a choice: listen to his team and protect the profitable business they had built, or risk it all on a vision no one else could see. He chose to risk it all. He famously told his team that CUDA was so important they would rather go bankrupt than fail to deliver it. This wasn't just a new feature, it was a fundamental shift in the company's identity. From this point forward, every chip NVIDIA designed, from the cheapest entry-level card to the most powerful professional one, would be built around CUDA. For years, almost no one noticed. Wall Street analysts were confused. The gaming community didn't care. CUDA was a solution in search of a problem. NVIDIA was spending billions on a software platform for a niche market, while its main rival, ATI, was focused purely on making faster gaming cards. For a time, it looked like a catastrophic mistake. ATI's cards started to outperform NVIDIA's in-gaming benchmarks, and NVIDIA's stock price stagnated. They were losing ground in their primary war, all for a secret weapon no one knew how to use. But then, a small group of academic researchers working in an obscure field called machine learning discovered CUDA. They realized that the very architecture of a GPU, thousands of simple cores running in parallel, was perfectly suited for the type of math required to train an artificial neural network. What used to take months on a CPU could now be done in days on a handful of NVIDIA GPUs. The floodgates were about to open. The turning point, the moment the world unknowingly tilted on its axis, came in 2012. It was an annual academic competition called the ImageNet Challenge. For years, the world's best computer vision programs had struggled to teach a computer to accurately recognize objects in photos. Progress was slow, with error rates stuck stubbornly around 25%. Then, a team from the University of Toronto, led by a researcher named Alex Krujewski, submitted a neural network called AlexNet. When the results came in, they were staggering. AlexNet had achieved an error rate of just 15%, a quantum leap in performance that shattered every previous record. The academic world was in shock. How had they done it? The answer was a secret weapon. They had trained their model on two off-the-shelf NVIDIA gaming GPUs using the CUDA platform. This was the shot heard round the world, the big bang of the modern AI era. Suddenly, every AI researcher on the planet realized that the key to unlocking the future of their field was not some custom-built supercomputer, but the very same hardware that teenagers were using to play Call of Duty. And because NVIDIA had spent nearly a decade and billions of dollars developing CUDA, they were the only company with a mature, stable, and powerful software platform ready to go. They had a 10-year head start on everyone. What followed was a land rush. Google, Microsoft, Facebook, and every university and startup in the emerging AI space began buying NVIDIA GPUs not by the dozen, but by the thousands, and then tens of thousands. These weren't just customers anymore, they were partners. NVIDIA wasn't just selling hardware, they were building the very foundation of the new AI economy. They created specialized libraries built on top of CUDA for deep learning, making it even easier for developers to build and train their models. Their old rival, ATI, now owned by AMD, was caught completely flat-footed. They had focused entirely on gaming and had no competing software ecosystem comparable to CUDA. Intel, the undisputed king of CPUs, was in an even worse position. Their entire business was built on general-purpose processors, and they had completely missed the shift to parallel computing. While they were trying to build a competitor from scratch, NVIDIA was already on its fifth generation of AI-optimized hardware and software. The gamble had paid off on a scale no one could have ever imagined. The tiny niche market of a few thousand scientists had exploded into the most important technological race of the 21st century. By the time the world woke up to the AI revolution with the public release of tools like ChatGPT and Midjourney, the war was already over. NVIDIA had achieved a market share of over 90% in AI training hardware. They didn't just have a monopoly on the shovels in a gold rush, they had a monopoly on the physics of digging. So, how did a company that made hardware for teenage gamers secretly position itself to hold the keys to the future of civilization? They did it by seeing the world differently. While their competitors saw a piece of hardware designed to solve a single problem, making video games look good, NVIDIA's leadership saw a general-purpose parallel computer, and they had the courage to bet their entire company on a software platform that would unlock that hidden power for the world. The lesson of NVIDIA isn't just about vision, it's about the power of creating a platform. They didn't try to predict the single killer app of the future. They didn't set out to build an AI company. Instead, they built the tool, the engine that would enable thousands of other companies to build their own futures. They created a stage, and in doing so, they became the most important actor on it. While others were building better pickaxes, NVIDIA was selling the fundamental laws of metallurgy. Today, NVIDIA's position is unprecedented. They are not just a participant in the AI revolution, they are the primary gatekeeper. Their technology is now a critical resource, as vital to the 21st century as oil was to the 20th. This has elevated them from a simple tech company to a geopolitical force, with their chip exports now being a matter of international policy and national security. Their journey from a Denny's restaurant to the center of the new global economy is a testament to a long-term vision and the conviction to pursue it, even when no one else understands. It proves that sometimes the most powerful move is not to build the house, but to forge the hammer. The future of artificial intelligence is yet to be written. We don't know which companies will ultimately win the race to create true artificial general intelligence, but as the world barrels toward that unknown future, one thing is almost certain. Whatever it becomes, whatever it builds, it will be built on the engine that NVIDIA created, in secret, a decade before its time.